Assalamu alaikum dear students, welcome to Classical Method of Analysis in Organic Chemistry CHM 42242 Experiment number 3 Analysis of zinc plus 2 in sample solution. Here you can see in the picture sample solution of zinc plus 2 has been shown. Come to the introduction. Analysis of zinc in sample solution can be carried out by volumetric analysis or titrimetric analysis, which involves complex formation reaction, or in other words we can say that analysis of zinc plus 2 in sample solution can be carried out by complexometric titration. Complexometric word is indicating that there must be some complex formation during titration process. So this experiment is divided into two major parts. Part A is standardization of EDTA solution, and part B is analysis of zinc plus 2 in the given sample solution. EDTA is the ligand here and zinc plus 2 is the metal solution. Standardization of EDTA solution is carried out with magnesium sulfate heptahydrate, that is a white crystalline solid. It is considered a primary standard substance because it fulfills all the criteria of being a primary standard substance. It is available in its high purity form, that is 99.98%. It has a consistent chemical formula. It has high molar mass, 246.47 gram per mole. It does not absorb moisture from the atmosphere, that is, it is not hygroscopic in nature. It does not react with atmospheric gases like carbon dioxide and oxygen when exposed to air. It is highly soluble in water. All these properties of magnesium sulfate heptahydrate makes it a primary standard substance. On the other hand, if we talk about the ligand, that is ethylene diamine tetraacetic acid, EDTA, its short form, is known as a secondary standard substance. It is a white solid and sparingly soluble in water. Its abbreviation used in literature is H4Y because it has 4 ionizable H plus ions, as you can see its structure below. There are 4 ionizable H plus ion in its structure. EDTA is a secondary standard substance because it is hygroscopic in nature. It has to be dried in a oven at about 140 degrees centigrade for 2 hours before weighing. It is sparingly soluble in water, so its aqueous solution is not clear. To prepare a clearer solution, some amount of sodium hydroxide is added to the beaker containing EDTA to form disodium salt of EDTA, which is highly soluble in water. Its abbreviation now becomes Na2H2Y because it has 2 ionizable H plus ions. You can see in the picture below as well. 2 ionizable H plus ions and 2 ionizable sodium ions in its structure are present. If we talk about the physical appearance, so it is shown in this picture, the white crystalline solid. Below you can see the structure of magnesium EDTA complex. M is representing magnesium here, that is surrounded by EDTA ligand, that is a stable complex in comparison to magnesium indicator complex. In the start of titration, you will transfer 5 ml of 0.1 molar standard solution of magnesium sulfate to a 50 ml volumetric flask with the help of pipette. Make the volume of the solution up to the mark with distilled water, followed by its well shaking. Later, in calculation step, you will determine the concentration of magnesium sulfate solution. Next, you will transfer about 10 ml of stock solution of EDTA to a beaker with a measuring cylinder. Make the volume of the solution up to 100 ml with distilled water and shake it well. Don't forget to rinse the burette with diluted EDTA solution. Next, you will fill the burette with this diluted EDTA solution. Remove the air bubbles from the jet. After that, note the initial burette reading. It is not necessary to set the burette reading at 0.0 ml. Now, come to the titration. You will transfer 10 ml of diluted standard magnesium sulfate solution to conical flask. You can see in the picture below. The 10 ml of diluted standard magnesium sulfate solution has been transferred, is going to be transferred in the conical flask. After that, you will add about 10 ml buffer solution of pH10 with the measuring cylinder and few particles of solid trichrome black tea indicator to it. Upon the addition of trichrome black tea, a complex formation reaction will take place in the conical flask. Trichrome black tea indicator will form complex with the magnesium ions, that is pink or red in color, as you can see in the picture below. Equations for standardization of magnesium sulfate solution. Magnesium sulfate in its ions which are magnesium plus 2 and sulfate minus 2, equation number 1. In equation number 2, you can see when the magnesium ions are reacting with indicator, so indicator after the loss of proton forming the magnesium indicator pink or red colored complex. HIN with minus 2 is the form that exists at pH 10. That is the protonated form that exists at pH 10. Magnesium indicator complex starts to break after the addition of EDTA. Here H2Y minus 2 is indicating the EDTA. When it is added in the conical flask, what happens? The magnesium indicator complex that is less stable starts to break down and magnesium EDTA complex that is stable starts to form. Simultaneously, the indicator sets free and appears in the form of blue color. So you will see a combination of pink, red or blue color. You will see the picture of that combined color in the coming slides. Changes that are taking place during titration. After the addition of disodium salt of EDTA solution drop by drop from the burette to the conical flask, a new complex formation will start in the conical flask. The magnesium indicator complex will start to break down and magnesium EDTA which is colorless, will start to form. Because magnesium indicator complex is less stable and magnesium EDTA complex is more stable. And you cannot observe the formation of magnesium EDTA complex because it is colorless, as you have seen in the equation in the previous slide, where magnesium indicator complex was pink red in color, magnesium EDTA was colorless, and as magnesium indicator complex is going to be break down, magnesium EDTA complex is going to form. So you will observe a drastic change in the color of this solution present in the conical flask. होगा क्या, आपके पास रेड या पिंक कलर का जो solution है, that is because of magnesium indicator complex वो ख़त्म हो रहा है after the addition of EDTA. Magnesium EDTA complex is going to be formed that is colorless. As magnesium EDTA complex is forming simultaneously, you can see in the previous slide you have seen that along with the formation of magnesium EDTA complex, the free indicator is formed, that is blue in color. So pink, red, yeah, pink or red, and free indicator that is blue in color. Pink, red, and blue, that will give you a combination of these color. A combination of these color will give you the purple color in the conical flask for a while. Before approaching the endpoint, you will definitely observe the purple color in the conical flask. At this stage, you have to keep in mind that magnesium indicator pink red colored complex, magnesium EDTA is colorless, and free indicator is blue in color. Now, what will happen? Before approaching the endpoint, you will have this purple color, as you can see in the picture below. In the conical flask A, you can see the red pink colored magnesium indicator complex. After the addition of EDTA, magnesium indicator complex is breaking, magnesium EDTA is forming, that is colorless, and side by side there is the formation of free indicator. जब magnesium EDTA complex form हो रहा है तो magnesium indicator का जो complex था obviously that is releasing the indicator free. So indicator in the form of blue color is appearing. So ये जो pink, red और blue color है, it will appear in the form of purple color. You can see in the picture below the B conical flask जो आपको purple color show कर रहा है. At the end, you will observe purple color in the flask before the endpoint, and after the endpoint has been achieved, you will observe. After the completion of titration, a bright blue color will appear in the conical flask, as you can see in the picture below, indicating that all the magnesium indicator complex have been broken down. Magnesium EDTA complex have been completely formed, and Arachrome black tea indicator has been completely in its free ionized blue HIN-2. That is the representation for that free ionized blue form at pH 10. Now you will note this final Burette reading. After that, you will take the concordant reading. Reading is actually the volume of disodium salt of EDTA solution consumed to form the complex with magnesium ions present in 10 ml of diluted standard magnesium sulfate solution. This concordant Bury reading will be used to calculate the molarity of disodium salt of EDTA solution. First of all, you will transfer 5 ml from the sample solution of zinc to a 50 ml volumetric flask for the analysis or estimation of zinc in the given sample. Next, you will make the volume of the volumetric flask, stopper the flask, and will shake the solution well. After filling the burette, if necessary, with standard EDTA solution, you will note the initial burette reading. Then you will perform the complexometric titration. Now, you will have to transfer 10.0 ml diluted sample solution of zinc to a conical flask with a pipette. Then add about 10 ml buffer solution of pH 10 with a measuring cylinder and few particles of solid Ricram black tea indicator to it. A pinch of indicator is added to the conical flask. Upon the addition, what will happen? The indicator complex, metal indicator complex formation reaction will take place in the conical flask. Zinc plus 2 reacts with EBT to form zinc indicator complex known as zinc In minus 1. So it will appear in the form of pink or red colored complex. You can see here the structure of zinc EDTA complex as you saw in the previous slide, the structure of magnesium EDTA complex. If we talk about equations for analysis of zinc plus 2, zinc will react with indicator form zinc indicator complex that is pink or red in color. In the second equation, you can see when EDTA is added to the conical flask, this zinc indicator complex starts to break down and zinc EDTA, that is much stable complex, relatively starts to form and the indicator sets free. Indicator will show the blue color at pH 10. The free form of indicator will appear in the form of blue color. So this pink, red or blue color will appear in the form of purple color as an intermediate color of complexometric titration. In this slide, we will just recall the equations. The addition of disodium salt of EDTA solution drop by drop from the burette to the conical flask will be started. After the addition of disodium salt of EDTA solution to the conical flask, what will happen? A new complex formation will start. That means previously the complex that have been formed after the addition of indicator, zinc indicator complex, that is less stable, it will break, it will start to break, and zinc EDTA complex that is colorless, it will start to form. As zinc indicator complex is going to be break and zinc EDTA complex is going to be formed, so what will happen? Zinc EDTA complex that is colorless, आप उसको indicate नहीं कर सकते हैं, but zinc indicator complex that was pink or red in color, and simultaneously the zinc EDTA complex that is forming an indicator is setting free, that is appearing in the form of blue color. तो ये pink, red और blue color का pink, red और blue color का जो combination है, that will appear in the form of purple color. As you can see in the picture, the purple color in conical flask. Okay, before approaching the end point, again and in this slide you can see the three colors. Before approaching the end point, some pink color complex that is zinc indicator complex, some colorless zinc EDTA complex, and some blue indicator are present in the flask that will appear in the form of purple color. So from pink red to the blue, there would be an intermediate state of color that is purple. After the completion of titration, what will happen? A bright blue color will appear in the conical flask, indicating that zinc indicator complex have been broken down, zinc EDTA complex have been completely formed, and Urichrome black tea indicator have been completely appeared in its free ionized blue form at pH 10. Now you will note the final Buret reading, and you will take the concurrent reading for the sample as well. Here is a short video for the estimation of sample solution of zinc in the conical flask. Sample solution, 5 ml of sample solution that was buffered with 10 ml of pH 10 buffer, and in that a pinch of EBT indicator has been added. You can see the red colored complex, zinc indicator complex have been formed. This complex is now being titrated with EDTA ligand complexometric titration. You can see the red colored complex is going to be break, and from red to purple colored appeared, and then at the final stage you saw the blue colored substance that is indicating the formation of free indicator. Again, have a look on the complexometric titration, the red colored complex, zinc indicator complex, zinc indicator complex breaking down, zinc EDT complex is forming, and there will be a stage of purple colored complex form, and that at the end you saw the formation of blue color that is free indicator. Watch the video twice or thrice for better understanding of experiment. Thank you.